Okay, in this video I'm going to talk about our first inference rule for the OR symbol. That inference rule is called addition. So let's see some examples of this in English. So suppose I am human. Well, then either I am human or Los Angeles is in California. That's true. If I am human, it follows that either I am human or Los Angeles is in California. That's a valid rule. Also, either I am human or the moon is made of green cheese. That's true too if I am human. No matter what, if I am human, then both of these are true. So note, by the way, that the truth value of the right disjunct doesn't matter. It doesn't matter if the right disjunct is true or false. Because the premise is true, the left disjunct is true, and so the whole disjunction is true. And so these are valid inferences. At least they're valid inferences if OR is inclusive. That is, this rule we're looking at, which we're going to call addition, it's valid when OR is inclusive. But addition is not valid if OR is exclusive, this reasoning pattern we saw in the previous slide. For an exclusive OR to be true, one disjunct is true, but also the other one is false. And so, just because one disjunct is true doesn't follow that the disjunction is also true. It depends upon the truth value of the other disjunct. If the other disjunct is true, then the whole disjunction is false. If the other disjunct is false, then the whole disjunction is true. So addition is not valid, going from just one of the disjuncts to the whole disjunction. That's not a valid inference pattern when we're talking about an exclusive OR. But we're going to have addition be a rule in our system, and that's the reason why our OR is inclusive. So why would you do this? Why would you infer from P to P or Q? P or Q is less informative than P. It doesn't tell you as much as P. It tells you either P is true or Q is true. You don't know which one, though. It's more informative to just be told it's P. P is the one that's true. So why would you make this inference? Well, in one sense, I say who cares? The inference is valid even if it's silly, pointless, or whatnot. Even if you didn't have any sort of care about whether or not P or Q is true, in fact, it is true if P is true no matter what. But in fact, it's also informative in certain situations. So I might think, well, if I pass math or logic, then I will satisfy the quantitative reasoning requirement. Think, I pass logic. Well, I should be able to infer from these that I will satisfy the quantitative reasoning requirement. And there are different ways to it's valid to conclude that I will satisfy the quantitative reasoning requirement, but how does that work? Well, one way to do it would be to say, well, if I pass logic, then I pass math or logic, and that means the antecedent of this conditional is true, and so the consequent is also true. And so in that first step from I pass logic to I pass math or logic, you did addition. So why would you do addition? Well, because there are other claims that OR figures in, that disjuncts figure in. You have the disjunct, the other claim contains the disjunction, so you go via the disjunction to get an interaction. So here's just another example. If she eavesdrops or wears disguises, she's a spy. She wears disguises. It's valid to conclude she's a spy, but modus ponens alone doesn't allow you that because she wears disguises is not the antecedent of the conditional. So the argument is valid, but the reasoning to demonstrate its validity would use addition to get the intermediate claim. She eavesdrops or wears disguises from the second premise, and then use modus ponens with this disjunction and the first premise to draw the conclusion she's a spy. So again, I think you see that addition can be a useful rule. So in our logical language, what does addition look like? Well, so if you have square, then you can say square or circle, and you can summarize this as add, or if you want to, you can say add right, because you're adding onto the right of square. You can also put it on the left, so you could say if you have circle, then you can also infer circle or square, and we again say add or add left, because you're adding onto the left of circle. So add is fine, but you can also say add right or add left to save yourself a little bit of time. So if you want to get a disjunction, well, first get one of the disjuncts and then apply add. There are other ways to do it, but this is the most straightforward way and the one that you will be using in your homework. So in a lot of ways, add, our new rule, is like ADJ, our old rule. Add works with disjunctions. Adjunction works with conjunctions. And with addition, you're adding something new. That's why it's called addition. With adjunction, and you're joining what you've already got. And so you want to note that the premises are different. With adjunction, you have two premises, you're joining two things you've already got. With addition, you're taking one thing you've already got and you're adding something new. So in that way, they're different. They have different numbers of premises, and they produce disjunctions or conjunctions, but besides that, they're basically the same. It's a way of building a disjunction or a conjunction, and so that's what you'll need to do in the homework problems. So I will have some derivation examples using this rule in another video, so you'll want to check that out before you do the homework. So good luck deriving. If you have any questions, please let me know.